Most secondary URD cable systems carry power to individual homes or groups of homes. The cable that's used in secondary systems is generally different from cable used in primary systems. For one thing, secondary cable is made up of 3 conductors, 2 insulated conductors carrying 120 volts and a neutral. Secondary cable usually terminates at a customer's home at a meter cabinet. The fault locating process for secondary URD cable is basically the same as for primary URD cable. First, you verify that you actually have a fault. Then, you pinpoint the location of the fault, so the cable can be dug up and repaired. However, the specifics of the fault locating process are a little different for secondary URD cable. There's a variety of test equipment used in industry to locate faults in secondary URD cable. Here's one type, called a voltage gradient unit. Now, this unit consists of a transmitter, which supplies the test voltage, a pickup shaped like an A-frame, which measures differences in voltage between 2 points, and a detector, which converts the measurement from the pickup into useful information you can use to locate a fault. Now, this equipment is similar to the capacitor discharge equipment in many ways. It has a voltage source, a pickup, and a detector, but there are important differences. One basic difference is that since secondary URD cable is designed to carry lower voltages than primary cable, high test voltages cannot generally be used to locate a fault. In a few minutes, we'll watch how this voltage gradient unit is used in an actual fault locating situation on a secondary URD cable. Right now, let's examine how this test unit operates and look at the function of its controls. Here's an illustration of a section of secondary URD cable. The cable runs from a transformer to a meter cabinet on the side of a home. The secondary cable at the home has 2 insulated legs normally carrying 120 volts and a neutral leg. A fault can occur in either of the 120 volt legs. The voltage source for the test unit, the transmitter, is set up with its test lead at a right angle to the cable you're testing. We'll see why later on. A metallic ground rod is driven into the earth beside the transmitter. As voltage is applied to the faulted leg, current flows from the transmitter through the faulted leg, through the fault to ground, and back to the ground rod.